We're taught innovation is a well-oiled machine, starting with a problem and logically proceeding to a solution. But history rarely follows this blueprint. Progress often looks like a shattered glass flask, a pool of industrial sludge, or a messy pile of ingredients. Those three specific messes directly resulted in the creation of safety glasses, Vaseline, and Maggi noodles. This presents a contradiction. How does a useless mistake, destined for the trash, become a world-changing technological or cultural breakthrough? The difference comes down to active observation. Innovation happens when a mistake is met with enough curiosity to treat it as a result rather than a failure. Take the typical early 20th century chemistry lab. It is a space defined by fragile, highly breakable equipment. This is the environment where scientist Edward Benedictus was conducting his routine work. During an experiment, Benedictus inadvertently knocked a glass flask off his workstation, sending it plummeting toward the hard floor. The glass hit the ground and fractured instantly. But when Benedictus looked down, he saw a physical anomaly. The flask had retained its structural shape instead of shattering into pieces. Instead of sweeping up the broken glass, he investigated the internal chemistry. He discovered that a liquid film called cellulose nitrate had dried on the inside of the glass, acting as a binding agent that held the sharp shards together. This isolated chemical observation was eventually scaled into a massive industrial application. It gave us the laminated safety glass that retains its spiderweb-like integrity during high-speed automotive collisions. Safety glass exists because the inventor treated a failed, broken object as a successful data point worth studying. That same observational rigor applies to human behavior. In 1859, a chemist named Robert Augustus Chesesbrough walked into an oil field defined by grit and industrial scale. While the rest of the industry focused on extracting crude oil, Chesesbrough turned his attention to the daily behavioral habits of the rig workers. He observed them engaging in a seemingly gruesome medical practice. Workers took a thick, gelatinous byproduct called rod wax from the pumps, applying it directly to their severe cuts and scrapes. Chesesbrough recognized a functional utility in this industrial waste. He saw that the thick substance sealed wounds from the air and appeared to accelerate the healing process. The global Vaseline empire grew from this refinement of a grassroots adaptation to a hazardous environment. In 1884, Julius Maggi set out to engineer an affordable, instantaneous meal for the working class. To reach this goal, he abandoned rigid, methodical recipe testing in favor of spontaneous, unstructured experimentation in the kitchen. During one session, he haphazardly combined his raw ingredients, taking a powdered mixture of peas and beans and blindly throwing it into a pot of boiling noodles. Upon tasting the accidental mixture, he recognized that it produced the exact savory flavor profile he needed for the mass market. This moment of unconstrained play provided the final piece of the puzzle, turning Maggi's deliberate engineering goal into the ubiquitous noodle block found in kitchens today. From a quiet chemistry lab to a dirty oil derrick and a chaotic kitchen, the same logic applies. In all three instances, an individual suspended their frustration long enough to deeply interrogate an unexpected outcome. In this light, an accident becomes a sudden influx of unrequested, highly valuable data. Innovation requires the observational discipline to look past the frustration of a mess and find the data hidden in the debris.